Welcome to today's episode of Artificial Intelligence. Today we'll be focusing on the topic called swarm intelligence. I'll give you a brief overview of what swarm intelligence really is. Swarm intelligence is also known as SI, is a form of artificial intelligence where it aims to stimulate the behavior of swarms such as insects. Swarm intelligence is the collective behavior of groups of simple agents that are capable of devising solutions to problems as they arise, eventually leading to coherent global patterns. The study of swarm intelligence provides insights that may help businesses manage complex tasks, as it models insects such as ants, bees, and other highly organized organisms. Even though insects such as ants are small and have limited capabilities, they can complete complex tasks in swarms such as finding the shortest path to a food source, organizing their nest, synchronizing their movement, and travel as a single coherent entity. SI has been incorporated into many fields, including engineering, computer science, economics, medicine, and social sciences. Now, Ivan's going to talk about the uses of swarm intelligence in the management information system context.
In today's world, where information overload is so prominent, companies need a way to gather, organize, and process information to solve problems in operations. The use of swarm intelligence has four main features which are advantageous in its application of management information systems: flexibility, robustness, decentralization, and self-organization. Systems based off of swarm intelligence can easily respond to changes, large or small, and still continue to work. In other words, you can change many different variables feeding into the system and it will still calculate solutions. Secondly, these systems are robust. Even if each individual agent or member in the system do not succeed or do not complete their tasks, others can step in and complete the task. Furthermore, the use of SI results in decentralization. Each individual agent of the system has very simple and specialized tasks. On its own, the task provides a minimal amount of information. As a whole, conclusions can be made from the collective information gathered. Lastly, the SI provides for a system that is self-organized. This means that within the system, there is no central authority, and that each agent has their own task to do that helps with the overall goal. Next up, Lillian will give a brief overview of the common applications of swarm intelligence.
There are a few available software in the market currently for swarm intelligence. One example is Objective-C Swarm. It uses various models of swarm intelligence to solve problems. The two common models used are particle swarm optimization and ant colony optimization, which I'll later refer to as PSO and ACO. PSO is a population-based approach for solving continuous and discrete optimization problems. In PSO, simple software agents called particles move in the search space of an optimization problem. The position of a particle represents a candidate solution to the optimization problem at hand. Each particle searches for better positions in the search space by changing its velocity according to the rules originally inspired by behavioral models of birds. ACO is another population-based approach that can be used to find approximate solutions to the optimization problems. In ACO, a set of software agents called artificial ants search for good solutions to a given optimization problem. To apply ACO, the optimization problem is transformed into the problem of finding the best path on a weighted graph. The artificial ants incrementally build solutions by moving on the graph. The algorithm takes into account two major factors that should influence any action taken by these ant-like agents, which are the number of objects in its neighborhood and its similarities. The general idea is that ACO takes isolated items and performs data clustering to understand the patterns of the behavior to solve the problem. Ivan is now going to give a few examples of where swarm intelligence is applied.
Swarm intelligence has various uses within the context of management information systems. the main feature being the ability to solve key problems. Take the ant example previously mentioned, where each individual ant finds its own route to food. Together, as an ant colony, the ants travel through the most efficient and safest route through the use of pheromones from each individual ant. This concept of using individual agents as a decentralized system creates advantages for managing information. A delivery company can use the concept of swarm intelligence to help plan and adjust routes for delivery. The flexibility of the system allows for those who manage the trucks to adapt to road conditions as delays occur to truck deliveries already in progress. As new information is received from each individual truck, the system calculates changes to the routes. Again, swarm intelligence works as each individual agent, the truck driver, performs very simple and specialized tasks, driving the truck for delivery. Individually, one truck may not change a route for later deliveries. However, as a whole, 100 trucks relaying information can cause changes to routes later on in the day. This concept can also apply to door-to-door salesmen. Each salesman covers certain areas or streets in the attempt to sell their products. This occurs in various parts of a city. At the end of the day, information collected can be used to calculate new routes or new areas which have a higher probability of success to sell their products. The takeaway from this is that swarm intelligence can be used to solve problems by taking information and using it in such a way that helps companies manage their operations effectively. And lastly, Jet will explore the limitations of swarm intelligence.
Now, on to limitations. There are several limitations with swarm intelligence. The first one, for example, is that it takes a lot of time to gather the data, and with that time, it may cost a lot of money for the company. Second, using swarm intelligence is really dependent on the problem. Different problems may use different strategies, and swarm intelligence may not be the optimal solution to use. Third, individual performance and collective performance can be uncorrelated, and that a group of individually high performers can be outcompeted by a same group of individually low performers. By adding adversity to a group, it can be more beneficial than adding expertise. So you never know whether to use a lot of people or use more experts and use a less sample size. As for swarm intelligence systems, they are unpredictable. They produce improbable results, and thus the result may be surprising or unexpected. For example, if we move to mobile media, in the new technology industry, it may take a lot of time to use swarm intelligence, so it may not be advised that many companies use swarm intelligence as technology moves very rapidly. Also, the result you get from using swarm intelligence, as I said before, is unpredictable and it's a very improbable result. So you really never know what you're going to get from using swarm intelligence. And in the mobile media industry, if you can't predict what you're going to get from the swarm intelligence, it's really hard to move your company forward and rely on swarm intelligence as a basis for your success. That's all for today on swarm intelligence. I hope you learned something today and it will be useful for you and your company. Thank you.